Hello my fellow students. Today I am presenting potato battery, the principle of electrochemistry. Can a potato really power electricity? Sounds fake. But today we are turning an ordinary potato into a real battery. And the crazy part is, this experiment actually demonstrates the same basic science used in real batteries every day. For this fun experiment, we want 4 potatoes and copper strips. We can also use copper nails or copper coins in the experiment as well. And we also need zinc strips. We can also use galvanized nail or zinc nails as well in the experiment. And we also need wires. We can also use crocodile clips. Here I am using 2 types of wires, one green to represent positive and one black to represent negative. In this experiment, we need LED or digital clock as well. Here I am using 2 types of LEDs, one red and one green. If you have 3 potatoes, we have to use red one, and if you have more than 3 potatoes, we have to use green one. Firstly, we have to connect wires to the metal electrode, copper and zinc. This side acts like positive and negative terminals of the battery. After this is connected, the circuit is ready for electrons to flow through. Here I am doing one for you. Electrochemistry is about how electricity and chemical reactions are connected. Think of it like this. When chemicals react, they make electricity flow. And electricity can also make chemicals react. Here's the cool part. The potato contains electrodes, chemicals that help move electric charges. The zinc reacts chemically and releases electrons. Those electrons travel through the wire to the copper, creating an electric current. This flow of electrons in what we call electricity in a simple circuit. In simple terms, the potato acts like a bridge that helps energy move from one metal to the another. That tiny movement of electrons is enough to power small electronic devices. Here's one diagram for you. After some time, I have connected my wires to my metal electrodes. First, I have taken zinc strip connecting to black wire representing negative terminal. Then I have taken copper strip connecting to green wire representing positive terminal. Then we have to insert copper and zinc to the potato on each side, keeping at least 1.5 inch apart, making sure that they both do not touch, creating a short. When short happens, electricity won't pass through them. Now connect wires to each other and also connect LED shown according to the diagram. So I have connected my wires and now I have dimmed the lights so you can see the experiment. And voila! LED lights! Science is everywhere, even in your kitchen.